So these next two examples are asking me to evaluate an expression without a calculator. And these expressions are composition functions, or in other words, I'm composing one function with another. So this first example says the sine of the inverse tangent of 3/2. So we're going to start by saying, well, asking ourselves, what is the inside function doing? This is the inside function. We have to evaluate it first. Says the tangent of what angle is equal to 3/2? Well, when I take the tangent of some angle and get 3/2, tangent, the definition of a tangent function, says that this is going to be my y over x, right? The tangent of some angle is y over x. And we're going to represent the y value here on our graph and our x value. In other words, I'm going to draw a picture. So if I have this point out here, which we're going to say is 3 and 2, then I have the angle, right? The angle theta. Let me erase that one line. I have the angle theta represented by this triangle. And if I know that the y value is 3, the x value is 2, then I can find the r value here, which is what I need. So I use my definition of tangent to draw a picture. Now, so if I know x is 2, y is 3, then r must be, using Pythagorean's theorem, the square root of x squared plus y squared, which in this case would be the x squared is 2, so that's 4 plus 3 squared was 9, so 4 plus 9 is the square root of 13. So I found out that r is the square root of 13. Then I come in and evaluate, in other words, my angle theta at sine. Okay, so in other words, the sine of theta is given by definition of our trig functions, that would be y over r, and I just found out what x, y, and r happen to be, and that becomes 3 over the square root of 13, or 3 square roots of 13 over 13 if we conjugate the denominator. Okay, so we are first using our definition of trig functions to draw a triangle, right? And then we use our definition of trig functions to then evaluate the function for theta. Let's try that one more time with this next example right here. So we're going to look at the inside function first. Okay, so we're asking ourselves, the cosine of what angle gives me negative 5 over 13? Since cosine is supposed to be our function, right, and cosine is x over r, I'm going to kind of use that to draw me a picture over here. Okay, so I know that x is negative 5, so I've moved, I've got some angle theta, by the way, okay, and this is theta, and I can drop a horizontal line or a vertical line down, and I know I'm moving negative 5 in the x direction. I know that r, by the definition of our trig function, I know r is 13, and I need to find out what y is then. So for this particular case, x is negative 5, r is 13, and y is going to be, when I use Pythagorean identity, I find out that y is equal to 12. Okay, I can do that one in my head because I know that a 5, 12, 13 is a special triangle, or you can use Pythagorean's theorem to calculate it yourself. So I know this value, y value, is 12. Now we come back in and we say, well, the tangent of theta, because that's what I'm using here, the tangent of theta is equal to y over x, that's just the definition using our trig functions, and we replace y with 12, x with negative 5, and I'll just stick that negative in the front, and I found out that the tangent of theta is negative 12/5. And just to make sure that I've kind of done the negative and positive signs correct, tangent is negative in the second quadrant, so yes, this is the solution. And that's how you're going to do composition functions. You start drawing a picture of the interior function and then evaluate the outside at theta.